For static electricity removal, a new windless static eliminator, a power elimination situation at different distances, and ion balance. If it is 15 centimeters, test its positive wear first. We can see the positive decay time is 1.5 seconds. Next, we measure its negative decay. We can see that the time of negative decay is 1.06 seconds at a distance of 15 centimeters. Let's test its ion balance. See how it works. The test time is 15 seconds. The test distance is 15 centimeters. We can look at its ion balance. The maximum ion balance is 27.9 volts. The average is minus 4.6 volts. The minimum value is minus 25.5 volts. Can satisfy the electronics industry. Peak-to-peak requirements at plus or minus 35 volts. Next, we test. It has a power consumption of 30 centimeters. Balance with ions. Next, we test. A power consumption situation of 30 centimeters. And ion balance, we first measure the positive decay. We can see the case of 30 centimeters. Positive decay time is 7.91 seconds. Let's test negative decay again. We can see that the time of negative decay is 6.7 seconds. Here we go. Let's measure the ion balance again. We can see that our maximum is 29.4 volts. The average is 9.2 volts. The minimum value is minus 16.6 volts. Let's test it next at 45 centimeters. No wind to test power dissipation and ion balance. Next, we are in the case of 45 centimeters. Test the speed of windless static removal. Let's first test for positive decay. We can see that after the distance is adjusted further, we're going to kill it noticeably slower, but we are still effective in removing static electricity. We can see that the decay time is 43 seconds. Next, we test its negative decay. We can see that the time of negative decay is 35 seconds. Next, we will test it again. The ion balance at such a long distance. We can see the maximum ion balance is 20.1 volts. The average is minus 7.2 volts. The minimum value is minus 29.8 volts. Ion balance. The peak value is within plus or minus 35 volts.